All right, guys, welcome back. Okay, so it's going to continue on to example 17 here. Example 17 says determine the intervals of concavity for each function. Okay, so again, what we're doing, our first derivative, 4 comes down. 4 times 1 over 12 is 1 over 3 x cubed minus 2x squared minus 32x plus 5. Okay, so guys, there's our first derivative, and we're just using power rule to figure out this guy. Now, let's take out our second derivative, f double prime of x. 3 comes down, x squared minus 4x minus 32. Okay, so now we need to be able to do a number line analysis on this function over here. Now, so this is going to be a very nicely factorable second derivative, and that was kind of by design for this question. We get x minus 8, x plus 4. So the numbers we put on a number line here, we have negative 4 and 8. Okay, so and again, this number line is of our second derivative here. So our number line analysis here, I'm going to take a number less than negative 4, say negative 5. I get a negative times a negative, which is positive in this region. A number in the middle region, okay, let's say 0. We get negative and positive, which is negative for the region. And then in the last region, we get positive, positive, or positive in the last one. Okay, so what's this tell us? This tells us that f of x, no, not f prime of x, f of x is concave up on negative infinity to negative 4, and from 8 to positive infinity. Okay, so all we're doing, guys, very similar to what we did for increasing and decreasing functions, but for intervals of increase and decrease, we do a number line analysis on our first derivative. For intervals of concavity, we do a number line analysis on our second derivative. Okay, and that tells us the intervals of concavity. All right, so for part B here, x minus 2 over x plus 3. Let's take our first derivative. So we have to use our quotient rule. So we're going to go bottom, top, prime, x plus 3 times 1 minus top, bottom prime is just 1, over x plus 3 squared. The x's cancel out, and we have 5 over x plus 3 squared is our first derivative. Okay, then I'm just going to modify this a bit and say that f prime of x equals 5 x plus 3 to the negative 2. Okay, so now coming back over here, our second derivative now, the negative 2 comes down, negative 10 over x plus 3 to the negative 3. All right, so on our second derivative, so negative 3 is not a 0, but it's a value that makes our second derivative undefined. So we're going to look at this guy over here on our number line. Okay, now if I take a number less than negative 3, I have negative 10 over something negative cubed, or negative over negative. That means we're positive in this part over here. And a number greater than negative 3, say 0, I'm going to have a negative number over a positive number, and that means I'm negative in this region over here. So that means f of x is concave down on negative infinity to negative 3. F of x, oops, I messed it up. F of x is concave up on negative infinity to negative 3, and f of x is concave down on -3 to infinity. Okay, so guys, this is this is what we mean by concavity and points of inflection. Okay, so points of inflection are the points on the curve where the graph changes from concave down to concave up, or vice versa. And the intervals of concavity are found by taking the second derivative and then determining when's the second derivative negative and when's the second derivative positive, and how do we deal with those. Okay, very similar to the intervals of increase and decreasing functions, but we're doing this operation on the second derivative as opposed to the first derivative, and that's how this one works. All right, guys, I will see you in the next lesson.